Alrighty, everyone, welcome. This is a Simplifying Radicals podcast to kind of help you out. Several of you are struggling, and so hopefully this will help you out a little bit. And so what I've done is I've started working on this, and I have several examples. So what you're seeing here is this is Simplifying Radicals. This symbol here is called a radical. The number underneath is called a radicand. And then this number, which we don't normally see when it's a square root, is called an index. If it's anything other than a 2, we write it. Otherwise, we don't. There are two properties that go with this, and one's called the product property that says, and keep in mind the numbers have to be positive, and here b has to be greater than 0. What happens here is that if you have two numbers multiplied underneath a radical, you can separate them out. Here, if you have two numbers divided underneath a radical, you can separate them out. So it's called the product and the quotient property. And one of the things you want to pay attention to is the fact that if it's together, you can put it apart. But if it's apart, you can put it back together. And that's usually one of the rules that students forget. So let's just jump in and do a few of these and jump into the next piece. So what we have here is we're going to do this. All of these are going to be simplified. So we're going to do square root of 28. Now you can use the factor tree, and I don't have a problem with that, but I'll be honest, I don't normally do that. But if that makes it easier for you, please feel free to do that. And so what you have here is you have the square root of 28. Well, 28 breaks down into 4 and 7. And so what you're going to have is the square root of 4 times the square root of 7. That's a perfect square, and there is a square root table on my School Fusion page under Files, so please feel free to print that off if you like. So when you take the square root of this, you're going to get 2 square root of 7. Now the 7's not going to simplify because it's not a perfect square. Now let's do another one. Let's do square root of 68. Now this is one I don't know off the top of my head, so maybe I'll use a factor tree to do it. And so I know it's at least divisible by 4. Okay, I know it's divisible by 2. I'm going to try 4. So I'm going to put a 4 here, and then all I'm going to do is down here is just put in a 4 and just see what it works. And that goes into 1, so that's 4, that's 28, that's 17. Yep, there you go. Now this is a perfect square, this is not, so we're good. So underneath my radical, I'm going to have the square root of 4 times 17. I really don't like that, so let's go to a different color. So I'm going to have the square root of 4 times the square root of 17. So it's going to be 2 square root of 17. And that one's done. How about the square root of 60? Now I happen to know because we've actually done some of these before, so I'm not going to keep redoing them. I'm just going to look back and see what I did already. And so square root of 60 breaks down into 15 and 4. Alright, and so when you get that, the 4 perfect squares, so square root of 15, square root of 4, so that's going to be 2 square root of 15. And there you go. Now square root of 75, I think of that with money and quarters, so I know that this is going to be 25 times 3. So square root of 25, square root of 3, so 5 square root of 3. Okay? One number, very simple, just breaking it down. If you know your divisibility rules, this is not real difficult, guys. I'm going to erase it because I want to put one more on this page, and then I want to go to a different page and put something a little more complicated. So let's do 162. Now again, this is another one that I know I don't know off the top of my head. So 162 breaks down, what's half of 162? Excuse me, so that's a 2. And then that's half of that, that's going to be 81. Wow, look at that. A prime number and a perfect square. So what I'm going to have is when I take the square root of this, I'm going to have 9 square root of 2. Notice I always put my whole numbers out in front of my radicals. The mistake that I see students a lot make is if you put it behind it, it ends up being back under the radical when that's not what you meant. All right. So now these were pretty easy, not real tough. So now let's move it up and let's do some that have the product or the multiplication involved. So I'm going to go to another page. And so what I'm going to do here, this is going to be there. Now there's all kinds of ways to approach these, and it's really whatever occurs to you. These are separated, so I'm going to put them together, and I'm actually just going to say square root of 18. Now you could just break down the 6 and into a 2 and a 3 and still get the same answer. That's the nice thing about this process, is that regardless of how you approach it, everybody's going to get the same answer if they're right. Well, what I see is I see a 9 and a 2. So square root of 9, square root of 2. Whoops. So that's going to be 3 square root of 2. And it's done. This one I like just because it kind of keeps you on your toes. I have the square root of 2 times the square root of 5. So that's going to be the square root of 2 times the square root of 5, so that's the square root of 10. Well, they're both prime. Neither one of them are going to break down. They're not perfect squares. This one's actually done, so that was kind of a little tricky. Okay, let's have square root of 5 times the square root of 10. There's another one. We actually did this example in the practice. For those of you who have seen it, fifth block still hasn't seen that. So you can put this together as square root of 50. Again, I see 25 and 2. So square root of 25 times the square root of 2, I see 5 square root of 2. All right. And then the last one, people were asking some questions about this kind. This is what happens when there's a number out in front. I'm going to put this one on a separate screen. And so you have 4 square root of 10 times 3 square root of 6. Now, one of the things you want to think about is the fact that the rules for numbers haven't changed. So the numbers out in front are still going to get multiplied. So basically, I'm going to have 12 times the square root of 10 times 6. Well, that's 12, times the square root of 60. Well, I've actually already done square root of 60 if you remember. So I'm not going to do it again. I'm just going to go back and look and see what I did. And square root of 60 is actually 2 square root of 15. So I'm going to have, and let me get my pen back, 12 times 2 square root of 15, because I already did 60. I don't see any reason to keep doing it. Okay, so I'm going to multiply 12 times the 2, so that's going to give me 24 square root of 15. Those are the different ones that you're going to run into with the multiplication. Now, let's look at some with the quotient. All right, so we're going to go to a new page. And so the first one we're going to do is, let's do a one that's really simple. Square root of 100 over square root of 121. If you didn't know, these are both actually perfect squares. So the square root of 100 is 10. The square root of 121 is 11. That's actually done. All right. Here's another one. Square root of 75 over the square root of 3. Remember, just like if it's together, you can pull it apart. You can put it back together. So I'm going to change this to the square root of 75 over 3. Well, the reason I do that is because, and let's erase that because I'm going to run out of room. 75 divided by 3 is 25. So I have the square root of 25, which is a perfect square. So I have a 5. That problem is done. Again, one of the things I definitely want you to see is there are lots and lots of ways to approach this. Let's look at this one over 18. Well, now we all know this reduces down to 1/2. So let's do the square root of 1 over the square root of 2. Now we all know that 1 is a perfect everything. So the square root of 1 is 1 over the square root of 2. Now we have to do what we call rationalizing the denominator. In other words, we want a whole number in the bottom. So what is it going to take to do that? Well, what it takes is you multiplying the top and bottom by the square root of 2. And you end up with square root of 2 over, this is 2, because the square root of 2 times the square root of 2 is the square root of 4, which happens to be 2. All right, and there's your answer there. Another one that I see that I kind of like is what happens when they're separate. So we have 3/4 times 5/2. I can do 3 times 5, this is 3 times 5, over 4 times 2. So I can do square root of 15 over 8. Again, there's so many ways to approach this. So I'm going to do square root of 15 over square root of 8. Okay, but I know 8 has a 4 and a 2. So basically what I have here is I have square root of 15 over 2 square root of 2. Again, that's something you can do because that's a very simple one. I'm going to multiply top and bottom by the square root of 2 because, again, this is one of my no-nos. I cannot have a radical in the denominator for fractions, so I have to rationalize it. And now it looks like I've run out of room, so I'm going to write over here. So this is going to be square root of 30 over basically 4. Okay, because the square root of 2 times the square root of 2 is 2. It's square root of 4, which is 2. And then 2 times this 2 gives me the 4. this is going to be your answer. All right. And so hopefully that gives you a little bit more practice on that. I would definitely practice on the problems. I will try to get a answer key posted that you can check that, so that way you guys can do this on your own. All right. Well, thank you very much.